Now, in this first video, we'll learn about Chaos Scatter. So Chaos Scatter is a powerful tool that allows you to distribute and instance objects in your scene quite easily. Even though we have the powerful MoGraph system in Cinema 4D, still it's a very welcome addition to V-Ray as it has some unique features and it might be easier to use for certain use cases. Now, I'm not going to use any fancy tree or flower models for now. Let's just use some basic primitive objects to see how Chaos Scatter work. Then if necessary, we can use more complex objects.
Hey folks, welcome to MoGraph Plus. This video is a free sample from our course, The Ultimate Introduction to V-Ray for Cinema 4D. It's a massive 13+ hours course in which we explore all the aspects of V-Ray for Cinema 4D thoroughly. Make sure to check it out. The link is in the description. Also, be sure to subscribe and ring the bell to get notified about our latest videos.
In this scene, I have this cube, pyramid, and cylinder objects, and I want to scatter them onto this 1000 by 1000 centimeters plane using Chaos Scatter. First, from V-Ray menu, add a Chaos Scatter object to the scene. So the first thing you need to define is the distribute on object or objects. In this case, we want to distribute on this plane, so let's add it to the list. Next, we need to define the objects we want to scatter. Let's select the pyramid, cube, and cylinder and simply make them the children of the Chaos Scatter object, and this will add them to this instance children list as well. Now, as you can see, those objects are scattered on the plane. To control how the scatter objects are displayed in the viewport, you can come to this viewport display tab and change the preview type from wirebox to full, as we are dealing with very simple primitive objects that do not require much memory if displayed fully. The next thing you probably want to control is the number of the scattered objects. And for that, you can come over to this surface scattering section and use this count number. Right now, we are scattering 1000 objects. Let's try 100. We get fewer instances. Let's try 500. And let's get back to the default 1000. But you realize if I try anything more than 1000 instances, maybe 5000 for example, we wouldn't get any more instances than 1000 in the viewport. But we would get our 5000 instances in the final production render if we basically wanted to start a production render. The reason we can't see more than 1000 instances in the viewport is because in the viewport display section, the max instances value is set to 1000. So no more than 1000 instances can be displayed in the viewport at the time being. Let's set it to 10,000 so we can see all of the 5000 instances that we defined in the surface scattering section and have some room if we wanted to get more instances and increase the number of instances in the surface scattering tab. Now, the next thing you probably want to control is the frequency of the distributed objects, and this is one of those unique features that it is a bit harder to do in the MoGraph system, but you can do it quite easily here, and it's a very, very useful feature. Let's take a look at the instance children list. If I select any object in this list, you can see the frequency value for each object on its right side. And if you click on this arrow here, you will be able to manually adjust the frequency value. Now we have 3 objects and the frequency value for all of them is set to 1 by default. So all of them are equally distributed on the plane. Let's say we want to give priority to one of the objects, for example, the cube. And let's say we want to have 3 times more cubes compared to the pyramids and the cylinders. So select the cube and increase its frequency to 3. Now we have around 3 times more cubes compared to the other 2 objects. Now let's say we want to have more pyramids as well. We can increase its frequency to 2 maybe. And now we get more pyramids compared to the cylinders, but we still get more cubes because its frequency is higher than the pyramids. If we want to see just a few pyramids, we can either increase the frequency of the other two objects or decrease the frequency of the pyramid instances. Let's take the latter approach and decrease its frequency to 0.1. Now we only see a few pyramids. You can play around with these values to get more comfortable. I tend to stay between 0 to 1 for all of my frequency values. That way it might be a bit more manageable in more complex scenes, but it's up to you. In this case, I want all of them to be equally distributed, so let's set the frequency for all of them to 1. Next, you probably want to be able to control the transformation of these instances, and for that we have this transformations tab. Let's take a look at the rotation section first. So the X and Z rotations are set to from 0 to 0, while the Y rotation is set to from 0 to 360 degrees, and that is why all the instances have a random rotation value on the Y axis from 0 to 360. If I set it to from 0 to 0, they will all have the same orientation. But in most cases, you really want that random rotation on Y for your instances. That is why by default it is set to 0 to 360 degrees. We can also have random rotations on X and Z as well if we wanted to. It doesn't have to be a random rotation. So if I zero out all the rotation values and let's say want to rotate all the instances on X for 25 degrees, I can use 25 as the from and to values for the X rotation. And now all of them are rotated exactly 25 degrees on X. For now, let's use the default values. If I get back to the viewport display section, just making sure the max instances is set to 10,000, and I'm gonna do the same thing to the count value under the surface scattering section and make sure it is 10,000. So we get a bit more instances. A quick tip, sometimes you might notice when using chaos scatter, IPR or interactive rendering in the viewport or in the VFB would be limited to the same viewport limitations, and you might need to run a full production render to see the actual result of the chaos scatter and the actual number of the instances. Let's get back to the translations tab. You notice we have the same set of values for the scale of the instances. Right now, uniform scaling is enabled down here. So the scale values represent the scale of the instances on all axes. Right now, the form and to scale values are set to 100%, so no random scaling. Therefore, all the instances will have their original scale. Let's add some variation and randomness to the scale of the objects. We can achieve that by using two different scale values for the from and to scale parameters. Let's set the scale from to 0 and scale to can remain at 100%. Now all the instances are scaled between 0 to 100% randomly. If we want less variation, we can use closer values like 50 and 100%. For now, let's set it to 100% for both of them. And finally, using this translation section, you can control the position of your instances and add randomization and variations to them. In this case, let's say we want to randomize the position of our instances on the y-axis. So let's change the from and to values to 0 and 500 centimeters. And now the instances are distributed across 5 meters on the y-axis. Or we can set them to 0 and maybe negative 30 centimeters. Now some of the instances would be placed lower than the plane surface. For now, let's go from 0 to 500 centimeters on y. You notice there is a stepping parameter for all the transformations. We have this stepping distance for the translation, this stepping angle for the rotation, and this stepping percentage for the scale. The stepping parameters allow to control the randomness that we can introduce with the other parameters. So for example, right now, all the instances can be at any point on the y-axis from 0 to 500 centimeters. If I set the stepping distance to 100 centimeters and made sure the stepping is enabled on y-axis, which is by default, you notice suddenly the instances are more organized. And that is because we have defined 1 meter or 100 centimeters as the stepping distance. So that means all the instances need to be positioned at 1 meter increments and no instance can be positioned in between. So in this case, we have instructed the chaos scatter to scatter the clones or instances on the y-axis from 0 to 5 meters. Then using this stepping distance, we ask chaos scatter to instance them on 0, 1, 2, 3, 4, or 5 meters exactly and avoid placing any of them on in-between values, like 2.3 meters, for example. And the stepping parameter for the scale and rotation does the exact same thing, but for the size and orientation of the objects. For now, let's zero out the translation values and get back to the default stage. If I get back to the surface scattering tab, you notice we can define a distribution texture. Here we can use a map to control the distribution pattern of the instances. Let's use this scratchy texture as the distribution pattern. You notice where the texture is black, we get no instances, and where it is white, we get our instances. So you can use black and white maps to control exactly how you want your instances to be distributed. For now, let's delete the texture. Now let's talk about slope limitation, which is a pretty cool feature. If you come down, you see this slope from and to values. Let me quickly hide the chaos scatter geometry and select the plane geometry that we distribute our instances on. Here I have a displacer modifier with this height map defined as its displacement map. And if I enable it, you notice it gives us this simple terrain. Let's unhide the chaos scatter geometry again. Now, you notice the chaos scatter did not recognize the displacer, and to solve it, just go to the object tab and remove the plane and add it again. Now it is working. Let's get back to the surface scattering section of the chaos scatter. Right now, because this slope limitation angle is set to 0 to 180 degrees, the placement of our instances is not limited. But if I set the angle to 0 to 15 degrees, the instances will only appear where the base mesh is much flatter. So using this slope limitation values, I can specify where my instances are placed based on the slope angle of the base geometry. Maybe we can try something like 35 to 50 degrees. And now the instances appear only where the base mesh has a steeper slope and not on flatter areas. For now, let's set it to 0 to 180 degrees. Another thing you notice is that all the instances are oriented based off of the normal of the base geometry. But in a lot of cases, you want them to be oriented more straight in case of distributing trees or flowers, for example. For that, you need to go under the transformation section and come down to the rotation section down here and use this normal versus Y parameter. At 0, the instances will be oriented according to the normal of the base geometry, and at 1, they will all look straight up, and you can blend between the two extremes if you wanted to get more realistic results, maybe around 0.75 or something like that. For now, let's disable our displacer modifier and remove and add the plane again. If you look closer, you notice some of these instances are overlapping each other. Sometimes you want to avoid that and have a bit of space between each one of them. In Cinema 4D, we have the push apart effector, and here to achieve that, you can come over to the config tab and enable this avoid collision function. Let's enable it. At 1%, which is the smallest value you can put in here, you notice the individual clones are still overlapping each other. And if I set it to, let's say 100%, now no instances overlap another one. Obviously, we get less amount of instances when the avoid collision value is set to 100%. And you can use in between values to get a mix of the two. For now, let's have it disabled, and max limit here is the total number of the instances allowed in the final production render, which is set to 1 million. You can change also the seed value here if you didn't like the random distribution pattern of the instances to get a new one. You also have this scattering mode here. If you want to scatter on a spline, change the scattering mode to 1D on spline. If you want to scatter on a surface, like what we have been doing, use the 2D on surface mode. And if you want to distribute inside the volume of a geometry, use the 3D mode. Usually you want the 2D mode when using Chaos Scatter. One of the more exciting parts of the Chaos Scatter is this Areas tab, where you could define, include, and exclude splines. So here you can define splines where you want your instances to be or not to be. It would be better just to simply show it to you how it works. I have a few different splines in this scene already. Let's start with this circle, which is placed at the center of the scene, and unhide it. If I add this circle to the spline includes list, only the instances inside the circle will remain and the rest will disappear. And if I delete this circle from the include list and add it to the exclude list, the opposite will happen and the instances inside the circle will disappear while the rest of them will remain. If this wasn't a closed circle, the instances would be around the circle, or on the circle, depending on whether the circle was in the include or in the exclude list. Now let me remove the circle for now. Now we have this spline 01 as well, which is an open spline. If we solo it and take a look at it from the top view, you notice this spline goes through the instances in a curvy fashion. Let's unsolo it and add it to the include list. You see the instances along that spline remain, some of them at least, and the rest will disappear. Obviously, it looks horrible right now because there is no Fallof, but thankfully you have some options down here to define that. So if I select that spline in the list and click on this arrow button, these options down here become available. Using this near and far values, we can define the distance from the spline where the instances could be distributed and a fall-off range. If I set the near and far range to the same value like 100 centimeters, Now we don't have any fall off and we are allowing our instances to be distributed 100 centimeters to the right and 100 centimeters to the left of our spline. But if I use a lower value for the near distance compared to the far value like 0, so from 0 to 100 centimeters, now we start to introduce fall off in both scale and density of the instances. So when the near value is set to 0, that means the falloff will start immediately and the instances will start to become smaller and less dense as they reach the defined far distance where they completely disappear. Let's set the far value to 150 centimeters to get a bigger range for the falloff. The scale value here controls the size of the instances at the defined near distance, and the density controls the max density of the instances at the defined near distance. Now let's delete this spline from the include list and add it to the exclude list instead. Now select the spline and introduce some falloff by setting the near distance to 0 and far distance to 100 centimeters maybe. Now we have the opposite of what we had before. We can obviously add more splines. Let's take a look at the second spline which goes across the plane and add it to the exclude list as well and define the same 0 to 100 centimeters falloff for it. Pretty cool. And the last thing I want to talk about is the camera clipping function. Let's add a V-Ray camera to the scene and place it right in the middle of the instances. So let's say we want to render our scene with this camera and we want the scattering to only happen inside that camera view, which can be very useful if you are dealing with a very heavy and memory intensive scattering. So let's enable that function. We can just leave it at the render camera or define our own camera to see the clipping function in the scene. Let's do that and define our own camera. And there you have it. So depending on the scale of your scene, you normally want to have this extended view beyond the camera view for a few centimeters. If it's a small scene, to a few meters to get correct shadows and reflections in your camera view. You can also enable this near and far clipping to define the distance from the camera where the instances can exist. Now you can go ahead and use your own fancy trees or flowers and see what you can come up with. Cool, so that's about Chaos Scatter. See you in the next one.
Make sure to visit our website mographplus.com and check out our premium CGI and rendering courses for Cinema 4D, 3ds Max, Maya, Arnold, Corona, V-Ray, Redshift, and much more. See you in the next one.